What's going on, everybody? Today we have a very good problem for you guys called the final prices with a special discount in a shop. So this is a very good one. So it says we're given integer array prices where prices of I is the price at the if index in the shop. So there is a special discount for items in the shop. If you buy the if item, then you'll receive a discount equivalent to the prices of j. So where j is the minimum index such that j is greater than I, and the prices of at j, right, is smaller than the prices at I. Okay, so otherwise you would not receive a discount at all. So return integer array called answer, where answer of I is the final price you would pay for the if item of the shop, considering the special discount. So this is a very good problem, right? Pretty, realistic problem, which I like a lot. So what they're saying, we're giving this bunch of the prices of a whole bunch of items, right? And then for each item, we can apply, if we buy another item, right, we can apply the discount, right? And the discount is the price at that item that's smaller than the item, right? So for example, 8, right? If I'm buying the item at item 0, right? And then I'm also buying the item index 1, then I can go ahead and apply the discount. And discount is the difference between the two values, which is the original price minus the price for this particular item, right? Then that means I get a discount of 4 because 8 minus 4. Then I go ahead and add it here, right? So it's kind of what they're saying. For M0, the price is 8, right? And then we receive a discount equivalent to the prices at index 1, right? Because the discount is if I find a value that's smaller, a price that's smaller than the prices for the original item I'm buying, right? Then I can go ahead and apply the discount of the difference of the two prices, right? If the item's smaller than I am, right? And it's to my right as well, right? So the same thing for 4. We find a discount, which is 2, because that's the first item that's smaller than it, right? Even though 3 is technically smaller, right? But we want the first smaller one, right? That's kind of what this is. Okay, if I find the first smaller one, then we go ahead and apply the discount. 4 minus 2 gives you 2. That's why we return 2 as the answer, right? And the same thing here, 6. Find the first one. We don't care about 3. Okay, 2, 6 minus 2 gives you 4. Then I pay $4 for the item index 6, right? It's kind of the whole point, the whole gist, guys, right? So let's go to my whiteboard and try to come up with a way to solve this problem, right? And kind of think it through a little bit. And yeah, this is kind of how we're gonna go over right now. It's pretty nice PowerPoint, right? So the discount, what they're saying, right? So the goal is 2 for each item, right? At index I, right? We need to find a price to our right, right? That, such that, because the indexes are increasing, right? From left to right. So we need to find the first valid lower, we need to find the first valid lower price. The first valid lower price becomes the discount. So the math is like this, right? For the final price that I would pay for a particular item is the difference between the value of the item minus the lower value, right? If there's no lower price that exists, then I end up paying the full price, right? So that's kind of the game plan here. For each item, we go ahead and search for later in the array, right, to find a price that's lower than us. The first one that we end up finding, that's the discount that we're going to apply to our price, so that we can say, all right, this is the final price that we pay for this particular item. Okay, this is pretty good, right? So we starting off with the most brute force algorithm, right, which is pretty important here, right? And then we'll iterate from there and kind of, right? So the approach 1, right, that we're going to take is the non-clever way, the straightforward way, right? How we would do it, and not pretty not trying to be slick or clever, anything like that, right? So the brute force pretty much for each item is get all the item and the rest of the array, right? Right. So we have one for loop that's doing a linear for loop, right? And another nested for loop that iterates through every item starting at the index, right? Okay. And then we keep searching. All right, for item this, we search the rest of the array. And if we find anything, if we find a value that's lower than us, then we apply the discount. If we're don't want to find it, we just leave it as is, right? And then we go into do the same thing for the next item, right? So we see we're scanning a lot of repeated items over and over and over again, right? So doing it that way is not very good, right? Okay. So the bottleneck here, right? We are doing a lot of repeated work, and the time complexity is n squared, right? Too slow, very slow for large inputs, right? It's not really gonna cut it here, because every item triggers a full scan at the end of the array, right? Sometimes we're not finding a discount, and those things are not very efficient. We gotta be a little bit more clever about our approach. Okay, so you can kind of see this problem is kind of should really. So what is the ultimate goal for this problem, right? You know, for each index, right, we need to find the a value to its right that's lower than it itself, right? The first value that's lower than that particular value at that index. Okay, so you can kind of rephrase it to say for each element, right, find its next smaller element, right? I know we've done other problems, Sean, where we did find the index, right, the first index where the value was greater than it, right, which was called the next greater element, right? Okay, but for this one, where we want to find the next smaller element, and that's kind of how that's the ultimate goal here, and that's kind of how we're gonna phrase that thinking and apply kind of the same algorithm, right? The same logic here, right? Okay, to this particular problem, right? And then what did we end up landing on at that particular thing, right? We were faced with the same hurdles, the same problems, right? Where we were doing this nested for loop, right? And then we had to kind of switch our thinking here a little bit, right? And be a little bit more smarter about things and really apply a better one, right? You know, so we said that, you know, as we're going from left to right, we can add items and apply them, right? And then at future iterations, if we end up finding a value that's, you know, in this particular example, right, a value that's smaller than the value of the items waiting for a discount, right? Then we go ahead and use those smaller values that we encounter at later iterations and apply discounts for them, right? Yeah. So that's kind of what this is saying. We replace them on the and when a cheaper price appears on the bill, right, we check your cart, and then if there's a new discount, then we go ahead and apply it, right? So how the tool that was, you know, that we came up with was the monotonic stack, right? You know, the stack is that, you know, we were adding things, you know, in piles because we were checking the last element that we added in our stack was the first element that we check against the future price that we end up finding, right? And then it was monotonic, which means it can be strictly increasing or strictly decreasing, right? And the way that we were storing the things, right, made it so that the items were sorted either strictly increasing or strictly decreasing. Okay, and so that's kind of the beauty of things here, right? You know, so for this one, since we're trying to find the next smaller element, right? If the prices are strictly increasing, right, in the array, meaning that as I go from left to right, the items just keep increasing, right? Then the waiting area, the item inside of our stack, will be strictly increasing as well because we never encounter smaller elements at later iterations, right? That can help, it can help to apply the discount to. Okay, so that's kind of what this is. We'll see how it's gonna all play out as we go ahead and apply this. Okay, so price increases, we put them in the waiting area, the stack that we have, and then the price decreases, then we go ahead and pop them out of the stack, right? That's kind of the thinking here. Okay, so the stack is last and first out. We always want to discount for the most recently added item. So that's kind of what we said, right? Okay, we just explained it. So yeah, so like I said, guys, right, the setup is going to be like this one, right? So we have input and we have an item, right? So this is our answer array. So we do a clone of the answer of the input array because, you know, if the items don't change, right, the value stays as is. Okay, so we have a current item, we have our stack, the waiting area, right, and the prices index, we go ahead and stack is empty initially, so there's no conversion possible, so we go ahead and push it into the stack, right? 8 star, we just go ahead and push it, add it to our stack. Okay, so we go ahead and we add so we add 8 to it, right? So after that, right, we go into x4, that's the current item that we're on. Okay, so now what will we do, right? So since we do check 4, is the item waiting in our stack, right? Is this item, is it smaller than this item going in our stack, right? Can it help resolve, right, the item that's waiting in our stack, right? Item can help resolve items in the stack if the price is smaller than the items waiting, right? If they're small, if the current item that I'm on is smaller than the items waiting in our stack, then we can resolve their answer, right? We can apply the discount for this particular example, right? So we go ahead and do this for yes, it is. Then we go ahead and pop it out, right? And then we apply the discount, which is 8 minus 4. And then we go ahead and push 4 so that 4 can wait at a later iteration. Hopefully it can find an item that's smaller than itself, right? Okay, so that's kind of the whole gist, right? So we push item and we wait at future iterations to answer the question, right? You know, are you smaller than I am? If you are, all right, apply the discount. Okay, so the same thing happens. We check current item is 6 smaller than the items waiting in our stack. No, it's not. Then it goes ahead and joins the list, the waiting area, right? Because it can't help answer the item, right? So we go into the next item, right? We see 2, right? 2 is smaller than 6, right? 2 smaller than 6. So we can go ahead and apply a discount for 6, right? You know, so you see how 2 is helping to clear the items that are currently in our stack, right? You know, because 2 is smaller. So 6 and 4, all they had to do was wait for future iteration to see if their answers can be resolved, right? If their problem can be resolved. Okay. So that's exactly what we end up doing, right? We do 2, solve 6, we apply a discount, 6 minus 2. We add 4 to our answer. Boom. Then we see 2 is less than 4 still, right? That's good. Then we pop 4, then we do 4 minus 2, right? We resolve it. Right? Now the step becomes empty. And then we go ahead and add 2 so that, you know, the same thing starts over again, right? We set 3. Is 3 smaller than 2? No, it's not. Then we add it to our stack. Bam, bam. Stack stays like that. Nothing changes. And it ends up being like, you know, those 2 would find a discount. So it ends up being like that, right? So that's kind of the whole thinking, the whole gist, guys, right? We were able to easily solve it, right? You know, instead of doing the double for loop, we went ahead and did the monotonic stack to help us to solve this in a linear fashion, you know, even though we introduced some sort of a memory, right? Hey, it's kind of, you know, a good trade-off to do, right? You know, so from going from n squared to the n time complexity, right? By applying this, right? So this is very good technique to master, to find the previous smaller, previous greater, and next smaller, next greater element, right? So this is a very, very good technique, guys, to master. And switching your logic, adding stuff in our waiting area, right? And then answering those questions at later iterations. That's kind of the main gist, guys, right? Instead of doing the double for loop, essentially. Okay. Let's now that we go understood the process, let's quickly go ahead and try to code that up real quick. Say, guys, code will be very, very simple for you guys, right? So what we're gonna do, we said we're gonna use our stack. Let's remove the auto complete because we don't do that here. So we have the stranger, we have the integer, and we have our stack, right? The rest of stack, okay? Which are our waiting area. Okay, so we have our stack that we initialize, and then what we're gonna do is to do a linear loop. Okay? Before we can do that, let's go ahead and initialize our result, which we're going to do. We said that we're going to clone the prices array because it will help us. And so we clone it because this is the clone of it, right? If we never found a discount for a price, it stays as is, right? So we clone it, right? Okay, so now we're going to do a linear loop. I equals 0, I is less than prices ln plus plus. So now we said that, in our stack, we're going to push all the prices. We push the every price to our stack, right? Okay. But also, right, before we do that, we check is our waiting area, right? Is it not empty? If it's not empty, then can I resolve any of the prices there? Right? So our stack at peak, we peak at whatever's there, right? And also, we should be adding the indexes instead, right? Because we can have, the values are not unique, right? So we can't really do that, right? So we add the indexes instead, right? So that we could reference, know which one we're referencing, which index we're referencing, and I'll be able to answer the questions, right? So if the prices, right? So the prices at that particular, if the current price, right, for the current current price. So for you guys, go to prices of I. All right, so whatever, so I'm doing the for loop, right? And then for the current price that we're on, right? If it is smaller, we zoom in so for you guys, so it's like very clear. Okay, is the current price so I'm to do is it smaller than the the price is waiting in our stack. If it is, then I go ahead and apply the discount that we said, right? Which is the results subtracting, so which is the stack that pop. Okay. We subtract the current price from it, right? Because its value is smaller than the price is currently waiting, right? So we subtract it and then we apply the discount. Discount has been applied. And then we go ahead and keep checking every time, right? Until that this condition is true. Okay. And then what's next for us to do is to push the index of that, right? You know, and then it waits itself as well, right? For future iterations, if we end up finding a price where the price is smaller than the price that we just added, right? Okay. Yeah, hopefully it made sense for you guys. After that, what we can do is to return the result, right? After applying all the discounts here. Here's where we apply the discount, we subtract it from it, right? It looks good to me. Let's press run code. Okay, this should be this one. Okay, if it's no, the same price or equals, then we go ahead and apply it. Okay, so this looks good to me. Let's press submit. Awesome, guys. We'll pass all the test cases, guys. If you guys found value, you guys understood the thought process, let me know that in the comment section. If you guys are new here, make sure to subscribe because we'll be doing a lot of other videos just like this one. So I want to thank you guys for watching, and I'll see you guys in the next video.